In this section, we're going to look at polynomials, particularly of the form x squared plus bx plus c. And what I want you to pay attention to in this section is that the leading coefficient here is a 1. And that's a really important distinction between section 3.5 and section 3.6. So we're going to look at multiplying binomials to get a trinomial. And then we're going to look at taking that trinomial and what we call factoring it. Remember GCF that we talked about. This time we're going to look at techniques to factor that trinomial back into two binomial products. So let's start with multiplying two binomials. We're going to look at three approaches here very quickly. We're going to look at an algebra tile approach, a rectangle model, and the distributive property, or just using algebra. So for example 1, we're going to multiply the binomial x plus 2 with x plus 3. And when we use algebra tiles, what we're trying to do is create a length and a width for a rectangle and use those two factors to fill in to get an area. That area is going to be our product and it's going to be our answer. So if we're looking at algebra tiles, here we have 1x tile on the outside of our guide here and three unit tiles. For the width here, we're going to have 1x tile and 2 unit tiles. So this demonstrates x plus 3 for the length, x plus 2 for a width. When we fill in underneath these two guide bars, we get this x squared tile, a positive x tile, a positive x tile, a positive x, 2 more, and then unit tiles. And if we look, we've made a rectangle, and I'd like to say no holes, no gaps, no pieces sticking out. It's a perfect rectangle that is exactly x plus 3 units wide and x plus 2 units long. And when I count up what's left underneath this guide bar, I have a 1x squared, 1, 2, 3, 4, 5 x tiles to add to that collection, and 1, 2, 3, 4, 5, 6 unit tiles. This becomes my area, which is my product. So I can say that when I multiply x plus 2 with x plus 3, the answer, or the area, is x squared plus 5x plus 6. What do you notice about the two numbers in the resulting trinomial? Where this is my trinomial. I have a 5 and I have a 6. And I want you to take just a second and compare that to the numbers in my two binomial factors, 2 and 3. What I need to think about is that 2 and 3 from my binomial factors, when I add them, I get 5. When I multiply them, I get 6. And that's going to be a really important pattern to notice in just a little bit. The rectangle model uses not individual tiles to draw, but it uses rows and columns. So each row and each column is going to represent one of the terms in my factor. So I still have a length and width. So my width this time I'll use my x tile here and plus 2, my first factor. I'm going to use the x from my second factor and a positive 3 from my second factor. And then I say, it's like Battleship. I multiply x with x and I get x squared. Keep going. X multiplied by 2 is a positive 2x. 3 multiplied by x is 3x. And 3 multiplied by 2 is 6. So then I look at the answer that I have here now. And underneath inside this rectangle model, I add my like terms. So x squared, 2x and 3x is plus 5x. My constant term is plus 6. Same answer as the algebra tile model, but a different concrete approach. The distributive property is a little bit different. So if I'm multiplying x plus 2, I'm not drawing tiles, and x plus 3, I'm thinking about multiplying every term in the first set of brackets with every term in the second. So I like to draw arrows sometimes, or you could write it like this. This x gets multiplied with the x plus 3. This positive 2 needs to get multiplied with everything in that bracket, the x plus 3. So I'm going to multiply my x with my x. I get x squared. I'm going to multiply my x with my positive 3, and that's going to give me plus 3x. I'm going to multiply my 2 by my x. That's plus 2x. And I'm going to multiply by 2 with my positive 3. That's positive 6. I can add like terms, and that would give me x squared plus 5x plus 6. Same answer, 3 different methods for you to choose from.